Hello students and welcome back to Mechanical Engineering Practice and Graphics. This week we're going to be covering the first and second chapters of the book. Today we will cover a quick introduction on SolidWorks, the environment and different kinds of documents that you can do in SolidWorks, how to define your units in the system, some quick gestures with your mouse, how to sketch in a plane. We're going to learn some tools to produce these sketches. And finally, we will finish with an exercise that is going to be graded. That will be the first homework of the semester. And I will help you with the first part, but you will have to finish by yourselves. First, I'm going to start with some announcements. This is the schedule of the semester for the lab. We are currently in week number 2. And we will be completing the chapters first and second of the book along with the first homework. Now, for those students that are already familiar with SolidWorks, we are encouraging you to take the challenge exam. I already have the format for the exam, and so far I have received the request from one student. But if there are any more of you that want to take the challenge exam, just send me an email, let me know, and then we can agree on a date to take this exam. Remember that the lab is the 60% of the final grade, so please try to finish these homeworks on time, since these represent 15% of the grade plus the attendance that is going to be graded on those homeworks. Okay, the textbook for this course is this textbook. It's called SolidWorks 2018. It's from Shamtico. Let's start. Okay, as I said last week, by now you should have SolidWorks already installed in your computer, if you have Windows, of course, or laptop. But if you don't have Windows, then you must use the Engineering VDI or the General Student VDI. The instructions on how to do this are available in Blackboard. And if you don't have a computer, you can request one to the UTSA's Tech Cafe, and they will provide a computer for you for the semester with SolidWorks already installed. Now, SolidWorks is a design software that engineers usually use for design purposes, also to define blueprints for manufacturing of those designs. And for academic purposes, we use SolidWorks to introduce the engineering analysis of these designs in a computer. So the first stage is the computer-aided design, CAD models. Basically, we represent parts, machines, assemblies, devices, rigs, basically anything, geometries using a computer. The computer maps basically coordinates of these geometries and features of these geometries. So all we're going to be talking about is geometry, basically. Now, these geometries define blueprints, define measurements, lengths, arcs. So all of these geometric information is drafted in a blueprint, and these blueprints help the person that is manufacturing these designs. This is just an example of a blueprint in SolidWorks. And also we can do what is called finite element method analysis. It's a mathematical technique that engineers use to analyze the mechanical forces and displacements that a mechanical component undergoes when subjected to loads. In this example, this is a hook, and these are the stresses that are inside the hook when subjected to maybe lifting an engine or whatever. And then there are criteria to compare with the mechanical response of the material and the deformation process of the geometry. So this is the engineering analysis. We are not really gonna talk much about this. This is just for an introduction on this. Okay, we're gonna focus in the design. So basically, I'm gonna provide to you blueprints, geometries, and you must do the computational representation of this information, either in 2 dimensions or in 3 dimensions. So let's get started. I'm gonna open SolidWorks. Now, since this is for those of you that are opening SolidWorks for the first time, you will have this license agreement. You just have to click in accept, and it will open. Once it opens, this window will pop up, and here we have 3 different modules. The first one is part, and that's when you just need to model one single component. The second one is assembly. In this module, you will put all of those single components together and assembly a machine or whatever. And then you have drawing, and in drawing you do the blueprints for either the single components to specify all the geometric information, or you can also do the blueprints of the assemblies, defining how to put together all of those components. Here in the top, we also have the regular menus or buttons like new or open, save, print, undo, and so on. And also, if you move your mouse in this small arrow, you will have the regular file, view, and tools. In this case, we're going to create a new part. So I'm going to click here in the blank paper. That's for creating a new part or a new document. And immediately it is asking me the dimensions that I'm going to use. In this class, we're going to use millimeters, grams, and seconds. And then I'm going to click OK. Now I have this menu, again asking me if I need to create a drawing, an assembly, or a part. In this case, I'm going to create a part, and I'm going to click OK. So this is the front screen of SolidWorks. Here on the bottom end, we have also the units. Remember again that we're using millimeters, grams, and seconds. You can also come here to options. And in options, you will have two headers, system options or document properties. I'm going to click in document properties. And here we have also units. From here, you can also define the units that you want to use. So there are those 2 different ways to define the units. Here on the left, we have the history. We have these 3 planes by default: the front plane, the top plane, and the right plane. We have also the origin of our coordinate system. So this point right there, that will be the coordinate 0, 0, 0 in the X, Y, and Z directions. Later on, I'm gonna show more information about this. Also here we have some other controls. Sometimes we use this hide and show button either to display the planes, either show primary planes. Also, if we want to see the origin, yeah, basically here we can hide items. Also, we have different representations of, of our creations. I'm gonna show the differences on this later during the semester. Appearances to render designs, to create section views, and also some others to zoom in or zoom out in the screen. Now, in SolidWorks, we use the mouse all the time. We can use the the scroll button. If we scroll up, we will zoom out, and if we scroll down, we are going to zoom in. If I press the scroll button and then move the mouse around, I can rotate the coordinate system. And if I press and hold Control in my keyboard along with the scroll button in the mouse, I can drag the coordinate system around. Remember that we are using 2 dimensions to represent a 3-dimension space. Always keep that in mind. Also, if you press your right click on your mouse and then drag it around, you will have several views by default. And depending on which module you are, those quick access controls in your mouse are gonna change. Now the modules are these tabs on the top part of your screen. We have features, sketch, markup, and etc. Most of the time we're gonna be using the sketch module and the features module. Sketch is to create drawings in a surface or in a plane. We can create lines, circles, squares, rectangles, many different geometries. And there are additional controls that we're going to be learning throughout the semester. And once we have those 2-dimension representations in a plane, then we can use the features tab controls to create 3D bodies. So for example, the extrude button is going to create an extrusion based on a cross section that you define. Or you can also create revolutions. To create cylindrical shapes or arcs. Okay. Going back to the presentation, just to see what we already talked about, what we discussed. Here on the top we have again the new document, open document, save document, and some additional controls, and also the file, edit, view, insert, tools, like the regular deployable menus that you have in any software. If you need help with any command, you can just click here, for example, sketch. And you can either have an access, a fast access to that control, or you can click F1 in your keyboard and it will take you to the help menu, and in here we can look for the help. So for example, sketch options, we have a very interactive help menu in this software. Okay, I already introduced a little bit about the tabs, so I'm gonna skip this part. As I was mentioning, the fast access controls that you have in your mouse, depending if you are in the sketching module or in the part module or in the drawing module, they're gonna change. Uh, so I'm gonna create the first sketch using lines. So let's go ahead and clicking the sketch tab. We're gonna click in sketch button, and then we have to select a plane. So for this one, I'm gonna use the front plane because we have x and y coordinates on that one, the front plane, and then I'm gonna hide those primary planes. As you see here, we have this dot with two arrows. This is showing us the origin of the coordinate system, and we must be aware of this point all the time when we're designing and drawing anything in SolidWorks, because all the coordinates and all the points, all the lines are gonna use this point as a reference. Um, so all the dimensions must be, you must be able to track down all the dimensions to this point. So usually when I'm going to start a drawing, I like to start using center lines. Now, usually center lines are gonna be discontinuous lines. These lines are not part of the design. These are just lines that we are going to use for construction geometries or as references. So the first one is going to be an horizontal and infinite length. Here, as you see, we have several options. I can either define a length, for example, and so I'm going to do that again, horizontal, and I can define a length. And if I press it, by default, it will have that length. Or if I press escape, I can redo that again. I can just draw it around anywhere. I'm gonna delete that one. I just click that and then I press delete. So the first step that I always do is I use a line for construction that is going to be horizontal and infinite that goes through that point, through the origin. That way I am aware all the time where the x-axis is at any given time. And also I do the same for the y-axis. Now as you see, I'm gonna do this line here, and you see that this line is blue, whereas these other two lines are black. What this color scheme is telling us is that the blue line is losing the space. I can move these points around anywhere and modify that geometry. And even when I specify maybe the length of this, let's suppose, I don't know, 50 millimeters. Since the line is blue, I can modify the location of the points, and therefore I am modifying the length of the line. Whereas these lines that are going through the origin, their position is already fixed. I cannot move them, and it means that they are fully defined. We want our drawings, our sketches, always to be black, because that means that the geometry is fully defined for the computer, that the computer doesn't have to guess any location. Now, you see these two green, these four green boxes along with each of these lines. These are called relations. Now this relation here is saying that the line 2, the one that is purple at this moment, it's horizontal. And this other relation is saying that the vertical line, the line 3, is vertical. And these other relations are saying that both of those lines are going through the origin or the first point of the sketch. Okay. These relations helps us to define also properties of geometries. So for example, let's create just a regular line. And then we are going to click in that line. We see that the possible relations for that line is either it can be horizontal or it can be vertical. The options are that it can be for construction, it means that it's discontinuous, or that it is infinite. Also, we can define the angle for that. We can also define the length for that line. Now, defining the length this way is not the best way because, again, I can modify that length by accident or by purpose. So the correct way to define the length of a line is using the Smart Dimension tool that is here on the top. And then we click anywhere in the line. So here I can define either the horizontal length or the vertical length between those 2 points, or just the total length of the line this way. And then I can also define maybe relative angles between 2 lines. So I can select first one line and then this other line, and I can define either this big angle or this inner angle. Let's suppose that this one is 45 degrees. Now as you see, now if I move one point, the other one will also move, preserving those 20 millimeters and preserving these 45 degrees. Now to add relations between a line or maybe a point and a line, we can click here in display and delete relations. Click in the second option that is add relation. And then we can click in this point, for example, and this line. And we can see that the only possible relation between a line and a point is that they both are coincident. And then we can click here in OK. Now if I move this point around, this point must respect this 20 millimeters, this 45 degrees, and this coincident relation. So let's create another relation between this point and this line. As you see now, all the line and the 2 points are black, which means that this line is defined, and then we will have this warning down here that is saying that the drawing is fully defined. This is what we want every time when we are doing drawings in SolidWorks, that everything is fully defined, and that means that I cannot move things around. And that also means that the computer knows exactly all the coordinates for all the lines and all the points in a drawing. Now, I'm gonna create this line here. As you see, when I move, when I was creating the line, my icon changes from a row to a pencil with a line icon underneath it. And then it appears, once I click, we can define the length. You see that the 10, 11, 12, 13, that's the length of the line. Now when it's vertical, it is also along with an angle of 90 degrees, or maybe 180, other 90, or 0 degrees. And then if it's horizontal, we have the horizontal box there, like a yellow box with a horizontal line, or if it's vertical, a yellow box with a vertical line. If it's 45 degrees, we will have like the icon of a sharp angle. So in this case, we're going to do a vertical line, and then look that once I'm going to do the second line, I'm going to show that the first line has this green box with the vertical relation, but also it has like a yellow square there. That's the midpoint of that line. We can see also sorry, we can also see, I'm going to do all of that again. We see that there are this yellow line coming from the last point, and also a vertical line. These are just references for a vertical line or an horizontal line from that point. And every time that I draw the next line, I will have those lines for constructions. I also have looked at if I move the mouse in a horizontal position of that center point, I will have like a restriction that I can use to define maybe that point there or there to create a triangle. So in this case, I created this geometry, and once the geometry is closed, we will see that the closed area would be in a dark gray color. Again, since none of these points are actually defined, they are free in the space, I can move them around, or I can just move everything together. Now to select everything, I just use the left click in the mouse and close everything inside of the selection box, and then I can move everything. Relation between two lines. If I click here in add relation between those two lines, they both can be horizontal, vertical, they can be collinear, they can be perpendicular if that is the case, or parallel. So for example, let's use this parallel, and now the base of this square, of this rectangle, is going to be horizontal. I can change the shape of that. A second trick that you can use with lines is, let's suppose that you create the first line and then I want to create an arc. So I can just move the mouse to the last point and then I can create an arc. As you see, there is a small cross there that is marking the center of that arc. We have the radius of the arc next to the pencil icon and also the angle that is enclosing. Half a circle, 3/4 of a circle, or maybe a full circle. So you can also create those arcs that way. You can create circles using this other option here. Using the circle types are, first you create the center of the circle and then one point in the circumference, or you can define 3 points of the circle. So that's one type, or the other one is using 3 points of the circle. Both of them will produce circles. We can create squares also using two opposing corners, or maybe the center and a corner, like this. We can create tilted rectangles or parallelograms, like that. We can create arcs as well. For example, I'm gonna move a bit further here, and there we have our arc. Also ellipses, if that is the case. We just define the center first, one of the dimensions or the lengths, and then the maximum length and the minimum length, or vice versa. Also this geometry that is called the straight slot, or maybe one with an arc, like this. Or we can also create polygons. We can define here the number of sides, for example, a pentagon or an hexagon. Okay. Another feature that is interesting here is we can soften corners using this sketch fillet. We select one corner and then we can select the radius of that corner. Maybe 5 is okay. And then we have that soft corner there. This is called a fillet. Okay, once we have finished a sketch, we can either click here in exit sketch or here in exit sketch, and that will create all of those lines and points in the space. If we activate again the planes, all of them are gonna be in the front plane. So if I rotate my coordinate system, you will see that all of those geometries are inside the front plane. Also here in the tree, we see that the first sketch, all of those lines are defined by this instruction here. And this one we can either hide, so nothing is there. We can suppress it. We can edit the plane of the sketch. So for example, if I want those drawings not to be in the front plane, but instead I want them to be in the top plane, I can just select a different plane and then click OK. And this time all of them are gonna be in the top plane. So again, I click on the sketch, I click in the edit sketch plane, and then I select the plane that I want them, in which I want them, and that's it. Or the first control is the most useful, is edit sketch. If I forgot to do anything in that sketch, I can click that, and then I'm gonna show you an easy way to go back to that front plane, because if I want to do it using the mouse, it's gonna be a little bit tricky, and that can produce problems. So I can just click Ctrl 8, the two keys at the same time in your keyboard. And that will take me to a perpendicular view of that sketch. By default, we have several default views in the keyboard. So if you press Ctrl 1, will be in the front plane. Ctrl 2 is going to be the back. Ctrl 3 is the left view. Ctrl 4 is the right view. Ctrl 5 is the top. Ctrl 6 is the bottom. Ctrl 7 is called isometric view. And Ctrl 8 is the one that we were using before. So I'm gonna discard these changes and exit. We already discussed how to create those circles and everything. Remember, once you are creating lines, that you can define all the parameters of the lines, the xy coordinates of the first point, xy coordinates of the last point, or if you know the horizontal length or the vertical length, also the angle or the total length of the line. So just play around with these controls. Also you have additional controls for circles and arcs. I forgot to mention the spline. I'm gonna do that. That one is a very special line. And this line is, you just create points in the space, and it will create a line or a curve that goes through each of those points. So the spline can be like this. It can be open, or we can create a closed spline. And then we will have these arrows that are denoting the tangent. How do we want the tangent of this line through those points? So I can make it longer. I can move it around. I can change the shape of that potato. And as you see, all of these modifications will have impact everywhere in the spline. These splines are useful when you are doing free design, like when you want just to create a smooth, good looking shape um, without a specific equation for that. So this is just to a nice tool. Now, what I'm going to show you now is the trim entities tool. I can cut portions of drawings. So for example, if I want to cut only the vertical line of this rectangle, I can just use the trim entities, and then I will click with my mouse. You see that I'm creating this shape, and whatever line that crosses with that shape is gonna be deleted. So for example, I'm gonna delete this line, or I can delete several lines at the same time. So for example, 1 and 2, and that's it. So the trim entities is if you want to delete things fast. Offset is also very useful. For example, let's use offset entity with this rectangle. And we can create another rectangle inside or maybe outside that one. So we have two features that are equal, but one is outside or offset from the first one. We can do it for closed loops and also for open loops, like this one. And then we can change the offset of that, or we can create two at the same time, like that. Um, this mirror entity is very useful, and I'm gonna show you here the purpose of that one. I'm just gonna move this mouse around. Uh, Basically, you click in mirror entity, and the first thing that you can do is you select the entity that you want to copy, in this case this circle, and then the mirror about is going to be a line that is going to be like a mirror for that. And I can either have both with activating the copy or deactivate the copy, and then the circle on the left is going to be deleted. In this case, I want to have both, so I will have it activated and then click OK. And as you see, it creates a copy of that geometry using this line as a mirror. I can use not only vertical lines, I can also use, for example, this line. Let's try that. Mirror entity. And that's it. I'm gonna move this one here. And I'm gonna show you also this linear pattern. So this one is also useful when you want to create a pattern of a given geometry. I'm gonna use this pattern. I'm gonna increase that distance, more of those, and then also in the Y direction. and immediately we have this pattern here. You can move things just selecting it and moving them around, or you can just click the move entities. And then you define the coordinates for that. Let's suppose 50 and negative 200, and then it will be down here. That's a way in which you can also move things with more control. You can copy entities, you can rotate them, escalate entities. This is very useful when you're doing the final project. Let's suppose that I want to escalate this. Like that. Okay. For the pattern, you can do also circular patterns. And that's pretty much all the control that you're going to be using in the sketch module. I'm going to accept these changes. Let's see what else. Okay, so this is the homework. I will need you to do these 4 geometries using the tools that we just mentioned. You can either do all of them in a single drawing or in separate drawings. SolidWorks files. And you will have to submit the SolidWorks files and also screenshots of a PDF file with screenshots of on how are you doing your homework. So I'm gonna help you with the first one, and then you can do all. Well, you must present all the 4 of these geometries. Let's start with the first one. So I'm just gonna create a new document, a new part file, and then I'm gonna click here in Sketch, and then I'm gonna select the front plane. Remember, the first step that I always do is to create this line for construction here, and another one that is vertical. Like that. Okay. For the first part, you can either do the whole part, or you can take advantage of the symmetry axis that this geometry has. As you see, this geometry is symmetric using this vertical line here. So we can actually do only 1/2 of this geometry, and then we can use the mirror entities tool to create the full geometry. So let's do that. I'm gonna use the line option here to create a line here, and then this one here. Now, as you see, I have this error. This line is not perfectly horizontal. I can just click here in horizontal option here in add relation, and that will fix that error. This line is 60 in total, but then since I'm only doing half of it, it's gonna be 30. 60 over 2 is gonna be 30. Now I can use math to do that 30 and write 30 there, or what I can do instead is I can click here in this point using the Smart Dimension tool, then click in this line for construction, and instead of placing the dimension here, I'm gonna place it here, and then I'm gonna click 60. And what it is gonna do is that it will recognize that I'm doing only half of the geometry, that I'm using this line in a future to create a mirror because this is symmetric. So it is recognizing that the distance from this point to that point on the other side is going to be 60 millimeters, which is what we have here. As you see, my mouse icon has a dimension icon next to it, and that means that the Smart Dimension tool is activated. So I can just define this dimension. In this case, it is 35 millimeters, as you see here. Then we have a shape that is like some stairs. So I'm gonna create that. It doesn't have to be perfect. Because we're going to define the dimensions for that here. This is 10. Also this other one is 10. But then we don't know the distance of this. We only know that the distance from this line, we don't know the length of this horizontal line, but we know the distance between the vertical line for construction that I have and this vertical line that is 20 millimeters. So I can use that. And then I have an error that is saying that I am over defining my sketch, so I can either make this dimension driven or I can just cancel this operation. I'm gonna proceed with OK just to show you the difference. Whenever a dimension is in light gray color, that dimension it's driven, and it means that the other dimensions are the ones that are actually defining that length. So I can just delete that one and it will not modify my geometry. Okay, now I'm gonna create an arc here, a 3-point arc, using this point here that it lies in this line, and any other point. And what I'm gonna do is I'm going to add relations between this point and this line. As you see, the center of this arc is gonna be inside this vertical line here. So let's add that relation between that point and that line. They both are coincident. And not only that, if you see, this center is also horizontally aligned with this line. So we can also add that relation there. So I'm going to create another relation between this point and this line, saying that they both are coincident. And that's it. As you see, the arc is in blue because I can change the radius of that arc. And the radius in this case is R10. R stands for radius, and this icon here, a circle with a line, that stands for diameter. Another one is this 2x. This means that there are two of those circles with diameter 10, and the two circles are the one on the right and the one on the left. And of course, this small circle here means that this is an angle, so this is 45 degrees. So we can define the radius of this one. This one is 10. And that's it. We have half of that geometry. Since I want you to start getting used to have your drawings fully defined, let's make each of the drawings in a single document. So you will be submitting 4 SolidWorks part files. So all the drawings can be fully defined. It means that you must have this fully defined wording here, and that all the lines and all the dots must be black. So we can then use the mirror entities. I'm going to select all these lines. And then I'm going to use the mirror about. I have to click here. And then I'm going to select this line. Then we can click OK. And we have our geometry. Now I can exit. I have that geometry there. And then I'm going to click here in Save As. So I'm going to go to my class, Slides Week 2. I'm going to click here. And I already created one, so I'm going to rename this as Lecture 3. My ABC123 is LJK354. Then this is homework 1, and this is the first part of that homework. And as you see, the save type is going to be SolidWorks part. It means that the file extension is either PRT or SLD PRT. And then I can click Save. Not only that, I can go back to the sketch, and then using this tool that you have in Windows that is called Snipping Tool, I can take the screenshot and then I can paste this in a Word document. I'm going to create a blank document and I can paste it here. And then I can paste all the screenshots that I take for this homework. Now, the SolidWorks part file has been saved, and I'm going to save this Word document as a PDF. So I'm going to save as, browse. Again, I'm going to go to the same location where I have it. Save. But then I can also click in export and create PDF. Publish. And then I will have my PDF with the screenshot of my homework. Now, why am I saving this also as a PDF? Sometimes when you save your SolidWorks part file and submit it to Blackboard, it can be corrupted. And that means that I will not be able to open your files. So in order for me to grade your homework, another option that I have is I can just check the screenshots that you take in the PDF file. And then I can grade this instead of the SolidWorks part file. So this one is saved. Then to create a new one, again, you click either Control N or click here in a new document. Create a new part. And then you can proceed with the rest of the homework. Remember to do all the 4 of them in SolidWorks, and also take screenshots of everything and submit it in the PDF file. Again, the guidelines for the homeworks are that this homework is going to be due on Sunday of this week. That's going to be January 31st at midnight. Any submission after that will not be accepted, and then it will be a grade of 0. Please remember to submit everything, all the SolidWorks part files and the PDF with the screenshots, as I just showed it to you. And use the file naming convention that is explained down here. Now, if you go to Blackboard, you will have this course, LME 1403. The L is for the lab. I'm gonna enter student preview. And then if you go in content, you will find the link for this video and the slides here in my sections in the week 2. Here is gonna be everything available for you. Also a brief explanation of the objective of this week. And then to submit your homework, you go to content and then you scroll down to submit homework here, and this is going to be the homework number 1. And in here you just have to browse your files and submit all the files here, and then you will click here in submit. That's it for this week. If you have any question, you can send me an email, or you can also text me in the group meet chat, or we can meet again also in the office hours. Remember that my office hours are Tuesdays and Thursdays from 10 a.m. to 12:45. Thank you very much, and see you next week.